Hello students, my name is Sumit Sagar Hota. I am a PMRI PhD scholar, IIT Palakkad. Today we will discuss week 10 of the live discussion section by Professor Asakdev sir, in which we will cover lecture 46 to lecture 50 of the subject Introduction to Airbreathing and Propulsion by NPTEL. The prerequisite for this course is you have to watch lecture 46 to lecture 50 by Professor Asakdev sir. Okay, this is the in this section we first study some of the MCQ questions. Okay, then we go for the problems. The type of rotary compressor used in airplanes is of dash. Okay. So the rotary compressor. Okay. So that means in the questions it's given rotary compressor. Okay. If it is given rotary compressor, that means there will be two options. Either it will be centrifugal or it will be axial. Okay, and airplanes is written. Okay, so this is the second clue. Okay, airplanes means there cannot be a what centrifugal, because the flow rate is very high. Okay, so the correct option is what? Axial flow. Okay, so answer is what? B. Next is gas turbine use following types of air compressor. Okay, okay, gas turbine. Now I show you the airplane, and airplane also uses what? Gas turbines. Okay, very lightweight gas turbines are there. Okay, so that means if in airplanes gas turbines are there. Okay, and again the question it's asked what gas turbine uses, so the answer should be what? Axial flow compressor. Okay, okay. So the answer is D. The axial flow compressor is preferred in aircraft gas turbine because what? Okay, you see the axial, that means it's kind of one advantage of the axial flow compressor. Okay, so we want axial flow compressor in where? Aircrafts. Okay, aircrafts means most probably what? Maybe fighter aircrafts. Okay, if it is a fighter aircraft, okay, that means and gas turbine. Okay, aircraft gas turbine. Okay, so that means gas turbine it's mentioned. Okay, and aircraft is mentioned. Okay, aircraft means most probably it will be what? Your fighter aircrafts maybe. Okay, so or commercial aircraft, or cargo. Okay, this may be three types of aircrafts you can take. Okay, this is not only fighter. Okay, so that means in all these types of aircrafts, what is the major concern? Okay, the major concern is the size. Okay, size of the aircraft is the major concern. Okay, so if the compressor having, okay, the area will be less, okay, the frontal area will be less, okay, then all these problems can be sorted out. Okay, drag will be less. Okay, so all these problems will be sorted out. Okay, the size is the major concern. Okay, so we have to what, we have to make the bigger size without affecting the what, with making the low frontal area. That's what the design approach. Okay, so okay, so that's the reason why most of the this aircrafts having low frontal areas. Okay, okay, because in the case of the axial flow compressor, what, low frontal area is there. Okay, okay, in axial flow compressor, exit flow angle deviation from the blade angle is a function of what? Okay, okay, you know very well that there will be a blade angle, or if the question is asked blade angle, okay, so it's obviously a function of what, blade chamber. Okay, that's the first, that's anyway you know. Okay, but the confusion arises that is it a function of other things, maybe space chord ratio, or only blade chamber, or is there any incident angle? Okay, you always remember that in this type of question, axial flow compressor exit flow angle deviation from the blade angle is a function of obviously a incidence angle also play a major role in it. Okay, we will see this thing in the problems. Okay, so the answer for this type of question. Okay, okay, an axial flow compressor gives optimum performance at dash. Okay, the power of axial flow compressor rises with the rise in speed. Okay, okay, and if the speed is high, okay, and the flow is obviously high, okay, that means the power of axial flow compressor gives optimum performance at high speed and the high volume flow rate. Okay, Okay. Okay, the axial flow compressor, the flow of air is dash to the axis of compressor. Okay. Okay, axial means obviously it will be what? Parallel. Okay. In the flow of air through the compressor is parallel to its axis, then the compressor is what? If the flow of air through the compressor is parallel to its axis, now only I told you, okay, it's obviously axial flow compressor. Okay, next these two types of question can be asked. Same question can be asked in two types. This is the second type. 6 and 7 same type of question. Yes, means same type, same question in different types. Okay, so the answer is C. Okay, axial flow compressor. Okay, the degree of reaction in an axial flow compressor is defined as the ratio of static enthalpy rise in the dash. Okay, okay, so degree of reaction. Okay, we don't care what is going on in stators. Okay, stator is a what? Fixed part. So whatever the stator option, just cut it. Okay, we only care about the rotor. Okay, so now again stator, wherever stator you just cut. Okay, here also stator is there. Okay, anyway now only one option left. Okay, that is C. So C is the answer. Okay, you don't have to know anything. If you know the basic, then you can answer this question. Okay, so the answer is the rotor enthalpy rise in the what? Rotor divided by enthalpy rise in the what? Stage. Okay, DOR is your what? Degree of reaction. Okay, the answer is C. In an axial flow compressor, the ratio of pressure in the rotor blade to the pressure rise in the compressor in one stage is known as what? Okay, so in this question, okay, I already told you what is the definition of degree of reaction in terms of enthalpy. Okay, and this is what the definition of the degree of reaction in terms of pressure. Okay, okay. Okay, so what is the answer? Okay, the answer is C. Okay, degree of reaction. Okay, the mass flow rate of air compressed in axial flow compressor is dash of centrifugal compressor. Okay, I already told mass flow obviously higher in case of what? It can withstand high mass flow rate in case of what? Axial flow compressor as compared to the centrifugal compressor. Okay, okay. The answer is what? Answer is B. Okay. The degree of reaction is usually kept dash for all types of axial flow compressor. Okay. So DOR for axial flow compressor is usually kept 0.5. Okay. The axial flow compressor has the following advantage over the centrifugal compressor. Okay. Okay. So you know very well the volume flow in case of axial flow compressor is very high. Okay. So that means it can handle what? Large amount of air. Okay. So what is the answer? Answer is D. Air handling per frontal area. Up axial axial compressor. Okay, air handling per frontal area is greater than for the axial flow compressor as compared to the centrifugal compressor. Okay. So answer is A. Okay. Now let's come to the problem part. Okay. An axial flow compressor was tested and found that it gave a pressure ratio of 3 atmosphere and a temperature rise of 125 degrees Celsius. A 2000 kilowatt motor was used to drive the compressor. Determine the compressor efficiency and mass flow of air delivered if the mechanical efficiency is 95% and pressure and temperature at the inlet were 1 atmospheric and 300 Kelvin. Okay, this is your question. Okay, so let's go to your solution. Okay, P2 by P1 equal to what? 3. Okay, pressure ratio given 3. Okay, then T2 minus T1 equal to what? 125 degrees Celsius. Okay, one temperature is I think given. Okay, 125 degrees Celsius is the what? 3 atmosphere and a temperature rise of 125 degree Celsius. Okay, and T1 you all already know. Okay, 300 Kelvin. Okay, that means now you can find out what? T2. T2 equal to what? 125 plus 300. Okay, that means your T2 is what? 425 Kelvin. Okay, okay, so for compressor means the process will be what? 1 to 2 days. Okay, that is the isentropic process. Okay, you can draw like this. because it's the only compressor, so only we draw the up to the compressor part, not the other parts. Okay, that to Excel Pro compressor. In TS diagram, this is your isentropic process. Straight line, and this is your actual process. This is 2, this is 2 dash. Okay, this is your T1 and this is your T2 dash and T2. Okay, so now you can write down the what for process 1 to 2 dash. You can write down the isentropic equation. T2 dash divided by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. Okay, T2 dash is equal to 300 into P2. What is P2? P2 by P1 already you know, 3. What is gamma? 1.4. 0.4 by 1.4. Okay, if you solve, you will get T2 dash as what? 410.62 Kelvin. Okay, it's done. Okay, now what is the efficiency of the compressor? Isentropic efficiency. Okay, is equal to T2 dash minus T1 divided by T2 minus T1. Okay, T2 dash I think you know, 410.62. T1 you know, 300. Okay, what is T2? 425, that's you know. This is also 300. Okay, and what is the result? 0.8849. Done. Okay, so you can write down it's maybe 88.5%. Now power conversion equation. What is power conversion equation? Okay, MA Cp delta T is equal to P into Nm. Okay, what is Nm? Mechanical efficiency. Sorry, time. Okay, time is your mechanical efficiency. Okay, so what is P? P is your input power. Okay, That means if you want to solve P input equal to MA Cp delta T divided by eta M. Now what is MA? Your input power is I think given, okay, 2000 kilowatt. Okay, just substitute everything here. 2000 kilowatt is equal to MA. What is MA? Okay, MA we need to find out. Now what is Cp? 1.005 for air. Now what is delta T? Already given. What? 125. What is Nm? Mechanical efficiency 0.95 given in the question. Okay, so substitute everything, then you get your MA as 15.124 kg per second. Okay, now a pressure ratio of 1.5 is to be achieved in a single stage of an axial flow compressor. The air approaches the rotor at an absolute velocity of 200 meters per second. Okay, now in this question a pressure ratio of 1.5 is to be achieved in single stage of an axial flow compressor. The air approaches the rotor. Okay, just a second. Okay, whatever. Okay, and a pressure ratio of 1.5 is to be achieved in a single stage axial flow compressor. Okay, the air approaches the rotor at an absolute velocity of 200 meters per second and at an angle of 12 degree. The speed of the compressor is 8000 rpm and has a mean radius of 30 cm. Determine the blade angles and a blade height if the mass flow rate is 10 kg per second. Condition at inlet are stagnation pressure 1 bar, stagnation temperature 300 Kelvin and compressor stage efficiency is 95%. Okay, so this is the question. So for this kind of question where lots of angles mentioned, that means what you can do, First you have to draw the triangle of the axial flow compressor, velocity triangle. Okay, that's the first work you have to do. Okay. This is your velocity triangle. This is your VW1. More specifically, you can write down VRW1. Okay, this is your real VW1. Okay. Okay, BF BR1 beta 1 12 degree given, B1 given, this is BF BW1 B1, everything given. Okay, so now what is blade speed? U pi dn by 60. Okay, what is the diameter given? Okay, in the question it's not mentioned your what diameter. Okay, but okay, so okay, so here okay, okay, no, it's given in the question. Uh, you see in the question it's mentioned the mean radius is 30 centimeter. Okay, so in the question it's mentioned mean radius means 30 centimeter means what? The radius will be 0.3 meter. Okay, if your radius is 0.3 meter, okay, so r is equal to 0.3 meter. Okay, if your r is 0.3, what is the d? Mean radius, mean diameter. What is the mean diameter then? 0.6 meter. Okay, so this will be your 0.6. And what is n? 8000 rpm is there. Okay, divided by 60. So now you get your u as what? 251.2 meter per second. Okay. Okay, so now what is Vw1? Okay, what is Vw1? Vw1 you can found out from the what? Vw1 how you found out? Vw1 you can found out from the triangle. Okay, sine 12. Okay, so what is sine 12? So what is sine 12? You tell what is sine 12? Sine 12 is equal to okay, so sine 12 equal to Vw1 divided by V1. Okay, so what is Vw1 then? Vw1 equal to V1 into sine 12. What is V1? V1 is here 200. 200 into sine 12. Okay, so what is 200 into sine 12? That is your 41.58 meter per second. Okay, so it is your 41.58 meter per second. So Vrw1 equal to okay, what is Vrw1 equal to what? U minus Vw1. What is U? Now we find out 251.2 minus 41.58. Okay, so Vrw1 equal to 209.62 meter per second. Okay, you get BRW1. Okay, now if you have BRW1, now you can find out your axial components. Okay, what is BF? BF from the triangle, what is BF? BF equal to B1 into cos 12. Okay, B1 cos 12. Okay, what is B1? 200 cos 12. Okay, then what is your BF? 195.63 meter per second. You get BF. Now what is tan beta 1? Okay, see the triangle in the tan beta 1. What is the tan beta 1? BRW1 divided by what? BF. And you know what is BF. And you also know BRW1, everything you know. That means you can find out beta 1. BRW1 divided by BF. 209.62 divided by 195.63. Beta 1 equal to 47 degree inlet blade angle. Okay, now what is the temperature at the inlet? T1 will be T01 minus B square by 2Cp. What is T01? Ambient temperature 300 given. What is B square? Okay, so B square is 200 square 2 into 1005. Okay, because it's in joule per kg Kelvin Cp. Okay, so if you do it, then you get your T1 as 280.1 Kelvin. Okay, so 280.1 Kelvin now you know. Now what is your T2 minus T1? Your T2 minus T1 equal to T1 into 1.5 is your what? Pressure ratio. It's given what? Pressure ratio is what? 1.5. Okay, and directly apply this formula. 1.5 to the power what? Gamma minus 1 by gamma. 0.4 by 1.4. What is T1? 280.1. Plus okay, but here we need only the difference, because in the formula next whatever formula we will apply, there actually we need delta t. Okay, so we need delta t, not t2. Okay, this is the formula. Okay, sorry, -1. This is the formula. When you solve, you get 34.4 Kelvin. Okay, again you apply the power conversion equation. Mechanical efficiency Cp delta T. Here delta T is directly there, so directly we write down delta T. Okay, no need of T2. If it is required in T2, then we can again find out. Okay, so Bw2 minus Bw1. Okay, so now from this equation we can now find out what Bw2 at the exit. Okay, or the outlet. Okay, that is equal to what? Bw1 plus Cp delta T divided by U into Nm, or the efficiency time. Okay, now substitute. Put in SI unit 1005, 34.4 Kelvin. U, you are 200. Okay, okay, so one thing here mistake is that U is not your 200. Okay, so what is U? What is U? U is your 251.2. So here 251.2. What is efficiency? 0.95. Okay. So when you solve it, you will get the value as 172.326. So here BW2 is equal to 172.326 meter per second. Okay. So you can now draw the same triangle for the exit as you drawn for the inlet. Okay, I just drag it and drop it, but you have to draw. U is same for both. Okay, either be inlet or exit. Okay. Okay, so we here find out what BW2. Okay, so now if you know what is BW2, then that means you can calculate from the graph figure. You can see from the velocity triangle, you can see we can calculate your BRW2. Okay, BRW2 we can find out what is this value, U minus BW2. Okay, what is U? 251.2. What is BW2? Okay, one 72.326. Okay. Now what is the answer? 78.87. Okay. then you can put your tan beta 2. BRW2 divided by what? BF. Okay, what is BF? BF is common for both inlet and outlet. Where is BF? 195.63. Substitute. Okay, if you solve, you will get beta 2 as 21.96 degree. Okay. What is the pressure at the inlet? Okay. So pressure at inlet. Okay. So just write down the pressure and temperature ratio. T01 to the power 1.4. P01 to the power 0.4 is equal to T1 to the power 1.4, P1 to the power 0.4. Okay. So what is T01? Tell what is T01? 300, 1.4, P01 given 1. Okay. 1 bar. Okay. So bar given, or what is the unit? 1 bar given. Stagnation pressure 1 bar. Okay. Stagnation temperature 300 Kelvin and compressor stage efficiency 95%. Okay. 1 bar it's given. So what is T1? 280.1 to the power 1.4, P1 to the power 0.4. So if you solve, you get the P1 as 0.78645 bar. Okay. You have the what? P1. And we know the pressure ratio always valid everywhere. Okay, pressure ratio, I think at inlet it's given, not a valid. If it is not mentioned, then valid everywhere. Okay, only pressure ratio mentioned. Okay, so P2 by P1. Okay, P2 by P1 1.5. Okay, so now what is P2? P1 you know. Okay, .18 bar. Okay, this is your P1. So get your P2. If you get your P2, now we find out T2. What is T2? because you know what is the temperature difference. We just find out here. Where is the temperature difference? Yes, see, temperature difference T2 minus T1 is what? 34.4. And what is T1? Your 280.1. Okay, then what will be your T2? The T2 will be 34.4 plus 280.1. That will be your T2. 34.4 plus 280.1. So what is T2? 314.5 Kelvin. What is rho 2? P2 by RT2. What is P2? 1.18. Okay. Where is P2? We find out. Now only we find out P2 1.18 bar. Okay, 1 bar into the power 10 to the power 5 Pascal. So 1.18 what is R for air? In joule per kg Kelvin. 287. What is T2? 314.5. But is now rho 2 you get 1.3 kg per meter cube. Okay, so now you know rho. That means now you can find out the what? Mass flow rate. Okay, I think mass flow rate given in the question. Yes, 10 kg per second is the mass flow rate. Okay, now you can apply that formula. So your m dot equal to rho 2 into pi by 4 d2 square minus d1 square into Bf. Okay, what is m dot 10? Rho 2 1.3 pi by 4 d2 square d1 square Bf. What is Bf? Bf always same, at in that around at 195.63. Okay, okay, so make it in a very crucial form like this: d2 square minus d1 square divided by 4 is equal to 0.01245. Okay, so now you can change this as d2 plus d1 by 2 into d2 minus d1 divided by 2. Okay, that is your 0.01245. Yes or no? So d2 plus d1 by 2 is, what is d2 plus d1 by 2? Your what? dm. Okay, mean diameter into d2 minus d1 divided by 2. okay, is equal to 0.01245. okay, so what is dm? 0.6 we found out from beginning. dm, what is dm? 0.6. okay, so just find out what is d2 minus d1 by 2. okay, if you found out, you get 0.024. Zero point 02075. okay, and what exactly this d2 minus d1 by 2? That means you can write down it as d2 by 2 minus d1 by 2. okay, okay, not write like this. okay, then what is d2 by 2 and d1 by 2? Your r2 minus your r1. okay, so what is your r2 minus r1? okay, difference between the two inlet and outlet radius. okay, what is the difference between the inlet and outlet radius? What it's called? What its terms as? okay, this is obviously your what? Height of blades. okay, so your height of blades is equal to 0.02075 meter or 20.75 mm. okay, this is your answer. So here in the question 3, I think one thing I asked is blade angle and the blade height. okay, this is your blade height and your blade angle it asked. okay, okay, blade means there is no blade angle means there's it cannot be one angle. okay, so okay, that means your beta 1, okay, beta 2, whatever things we just find out, that those are your what? Blade angles. okay, I think we find out all the blade angles. okay, okay, so this is also the answer. This is your answer. Actually, these are also the called as airflow angles. Okay, inlet blood angle. This is your inlet blood angle. Okay. Beta 2 is your exit blood angle. Okay, this is also the answer. This is also the answer. Okay. With this we can end this section. Thank you very much for attending the section. If you are watching the recorded one, thank you very much. Go through all these problems carefully and all the MCQ carefully. And if you have any doubt, you can ask me in my YouTube channel Sumit Sagar Hota, and also you can ask all the any doubts in the question and answer forum by NPTEL. Okay. Thank you very much. Good night. We'll meet next week 6 to 8. Happy learning.